Hello, welcome back to the Math AA SL course that I am teaching. Woohoo. Again, I do not have any credentials. I'm just using the official, yes, official IB book. I don't really know what the unofficial IB book would be, but who cares? So I'm doing 8.3 and 8.4 in this video because they're both very short. So 8.3 is about independent and dependent events and conditional probability. So when we say independent, we're referring to an event or a situation that doesn't affect the other situation. For instance, flipping a coin and rolling a dice. Just because you flip the coin, it doesn't impact the ability to roll the dice. Let's say you have 5 socks and you pick one of the socks and then you have to pick another sock. That would not be an independent event because obviously the fact that you already removed one of the socks from the drawer will lead to a different result than if all the socks were there. So what you have to know about this is the product rule for independent events or the multiplication rule for independent events. It's the same thing, it just has 2 names. So what this is, the probability of A and B, this means someone is partaking in both events, equals the probability of A times the probability of B. This would be like if we're doing art and people who take art and people who take music, you would take the people who take both art and music, and the probability of that would equal the probability of people who take art times the probability of people who take music. So the next and last part of this unit is about conditional probability. So conditional probability, as the name implies, means that the 2 events can affect each other. So if you do one of them, it could lead to a difference in how the second thing is done. So you would basically take this notation means the probability of A given that B has happened. So this would be like the probability of something happening if the other thing has happened. So the A would be the before, and you're checking what is the probability that these things happen after each other. So the formula for if you're looking at the probability of 2 events, it's the probability of A given B equals the probability of A and B, which is the intersection, divided by the probability of B. Now, for independent events, you use the probability of A given B is equal to the probability of A. So you would always use the first letter, yes. I don't know if that helps you remember, but for me, I just like to think, okay, the first letter in the A given B, even if it's B given A, whatever is first is the one that is equal to the probability of B or A, or, whichever letter is first. I hope I'm not confusing you. And that was it for 8.3. Now we're doing 8.4, which is the probability tree diagrams. So with these diagrams, there are 2 options that you can draw. There's the repeated events, and then there's the, again, what we were just talking about, conditional probability. So what the conditional probability refers to is without replacement. Meanwhile, repeated events has replacement. Now, what I mean by replacement will become very clear very soon. It's just I sort of need an example to explain what I mean. So for repeated events, let's take flipping a coin. So you're going to do this event many times. That's why it's called repeated. And each time, the outcome, you will only be able to get heads or tails, right? If you flip a coin, even if you flip it twice, it's not like suddenly you get another option. It's the same each time. And then how to make these tree diagrams is you put the heads and the tails, and then make 2 lines for another head and tail, and then another head and tail, and another head and tail, and you can take the probability of how to get there. So for the first heads, right, it would be half. It would be 50% chance. And then for the second tails, if you did like tails, tails, then you would have half again, and then half again, because it would be, there are only 2 options, so there's a 50% chance. And what I have circled here in black is the sample space. These are all the different options you could possibly get. And I put an example here. I did not use the right notation, so ignore that. But what I meant was the probability of 2 H's. Yes, which would be 1/4, since 4 of them have 2 H's in them. But yes, that's how you would do that. And then suddenly, while I was making this, I changed my mind with how I was setting this up and decided to erase everything. But don't worry, there will be an example of conditional probability as well. And I will make it even more clear what the difference is. So I've come up with a better example, and this is very inspired by my real life. It's called A Kitty in a Box. Here's a picture of my cat and its kittens, because she just gave birth to them like 2 days ago. So, in this example, you have 3 brown kittens and 2 gray kittens, and you're going to draw a tree diagram to show the probability of picking them out of the box. Now, in this situation, once you pick the cat out of the box, it's no longer in the box, which of course will affect the probability of the next color you pick out of the box. Now, if at every point I put the cats back in the box after picking them up, then you would say that's with replacement, right? I'm making sure that every time I do it, there are the same amount of cats in the box. Now, without replacement is removing them from the box. So that is what I meant by that. So let's say B is for brown, G is for gray. So initially, there would be a 3 out of 5 chance of picking a brown one and a 2 out of 5 chance of picking the gray one. And then, when going for the second kitten being picked out, there would be, for brown, to pick another brown one, the chances would be, right, there would be 1 less brown, which means there are 2 browns in the box now, and 2 grays, which means it would be 2 out of 4, which is 1 out of 2, right? And for gray, it would also be a half chance. Now, on the other side, if you picked a gray, and you're picking another gray, it would be, 0, right? It would be 100% brown after that. But if you picked 1 gray, then there's only 1 gray left, which means it would be 1/4. There would be a 1/4 chance of picking a gray one, and there would be a 3/4 chance of picking a brown one. Now, you could just make this diagram, longer until you have no kittens left. I'm not going to do that, though, because who can be bothered? But this is what I mean by conditional probability. Also, each one of these triangles, I'll call them, are supposed to add up to 1, right? So if you look at the first triangle, which is 3/5 and 2/5, if you add them together, that equals 1. And this refers to how probability is always between 0 and 1. Now, what would you say the chances are of picking a brown and a brown, like after each other? The probability of that would then be 3/5 times 1/2. Ta-da! That's how you do that. Now, if you wanted to do this with the repeated events with replacements, each time you would put the cat back into the box. So that would mean you would have the same probability each round. So then if you wanted to find brown, brown, then you would do 3 divided by 5 times 3/5 again, and it would be like that. And that was it for 8.4. Now it's time for the quiz. This quiz will be dealing with both the stuff from 8.3 and the stuff from 8.4. It's a very easy quiz though, so don't get worried. So question 1 is to do with this Venn diagram. Now your job is to find the probability of A given B, and is this an independent event? So in this situation, the A stands for art class and the B stands for biology. Now, for question 2, you have to find what type of tree diagram would this be. Now, for the marbles being picked but not put back. So you have a bag of marbles and you pick them, but you don't put them back. Now, the second question is if you have 2 black marbles in the bag and 6 yellow marbles, and it's not put back, what would be the probability of picking a black marble, and then a black marble, and then a yellow marble? Now pause and come back when you have the answers, or what you think are the answers, and we'll go through it together. So here I was an idiot and wrote the wrong thing. So the actual answer is 1 divided by 15, which is 0.067. Now, the reason why I did this wrong is because I, for some reason, found the probability for A or B, or I don't even know what I did. That was just stupid. But what you're actually looking for is the intersection. So the intersection would be 1 divided by 1 divided by 25, and then you divide it by the probability of A, which was 15 divided by 25. So for 2A, the answer was conditional because you are not putting a replacement. You're doing without a replacement. Now for B, I decided to erase the other questions so that I could draw an actual diagram to show you. So you have 2 black marbles and 6 yellow marbles. So initially, you're going to have 2 out of 8 to get black, or 1 out of 4. And you'll have 6 out of 8, or 3 out of 4. I don't know why I didn't simplify, but that's okay. And then to get another B, you have to remember you've removed it from there. So now there are 7 marbles in the bag, and there's only 1 black. So then it would be 1 out of 7. And then to get a Y, what would be left in the bag since you removed 2 blacks? Only yellows, okay? So that would just be a 1. There's no chance of you not getting a yellow. So then to find the probability of this, you would do 2 divided by 8 times 1 divided by 7 times 1. Or you can just ignore the 1, but yeah. And that's your answer. So that was it for these 2 chapters, and it was actually it for all of chapter 8. So put the blue check mark. Woohoo! We did it. We're done with chapter 8. Yes. This was also a very short chapter, like the previous 2 I did. Now, the next one will most likely be chapter 10, or I'll go back and do some old chapters that I've already gone through in school, since I'm doing this in the order of which I'm being taught it. So feel free to subscribe, like, comment, follow me at Johanna Frennert on Instagram, and goodbye! Thank you for watching. Hopefully you learned something. Yay!